Okay, so this is the video for the makeup for 22716 integration techniques. If we just go ahead and skip to the next page, we have all these different integrals. Okay, really, I'm going to go through this part pretty fast, but this whole k thing really just means you can move that k to the number. Notice that this is k times, not k plus. Alright, when you have this split up like this, where you have an integral of a sum or difference, it really just means you can integrate each piece separately. Antiderivative of du, that would just be u, again, plus c. Okay, this would be the basic power rule. So your new power would be n plus 1, and that's also what you would divide by. Okay, when you have a u in the denominator like this, 1 over u du. That's natural log of absolute value of u. You integrate it. Okay, don't worry about that one. E is for easy. The integral of e to the u is e to the u. Only thing that works that way. Okay, now let's think about the trig. The antiderivative of sine would be negative cosine. Okay, this one would be positive sine. Just use snow cone if you need to. This one would be tangent u. You need to know these. This would be negative cotangent u. It's just from your original 6 trig derivatives. This one would be secant u, negative cosecant u. Okay, before I get to the inverse, if you can rewrite these like this, it's going to help you be able to use natural log. Okay, this ends up being like this if you kind of go through the u substitution. This one's just going to be positive natural log of sine u. It's where you let the denominator equal u, and it works out as a 1 over u du. Okay, one of these is arcsine, one is arctan. You need to be able to recognize which one is which. And then this would be u. And then we usually have that over a. In this case, we would have a 1. Okay, but that could be a squared there. On the AP test, generally it's not. Same thing here. We have 1 over a. Alright, so I'm not trying to make this more complicated than it needs to be, but because these are 1s, that's why we have, this is more simplified here. Okay, let's look at these. Okay, so you're going to do 1 on your own. We're going to do 2 together. You know, when in doubt, if there's no parentheses, let u equal the denominator. Here's another way I knew this was probably going to happen. Look at your answer choices. They all have natural log in them. So it makes sense to let u equal the denominator. And then what we're hoping is that our du is the numerator. Now this is not exact, but it looks like I can divide or factor out a 2 and then actually divide that out. Okay, that goes right out in front of the integral symbol. And then I have the numerator right there. So I do have 1 over u du. Now this is the part where most people mess up. They forget about changing their bounds. So remember, these are x's, and we want to know what is the bound in u. So what is x squared plus 2x? Well, 2 squared plus 2x, that's going to be 8. And 1 squared plus 2x, that's going to be 3. Alright, so those are your new bounds. Alright, this becomes 1/2 natural log of u. And then your bounds, again, are 3 and 8. So you have 1/2 natural log of 8 minus 1/2 natural log of 3. And it looks like B. Excuse me. Alright, you're going to do 3 and 4 on your own, and then we're going to work through number 5. Okay, this is one that could drive you crazy because you could start letting u equal this and that. Don't forget that you can usually rewrite the problem. Okay, that happens quite a bit. So watch what I'm going to do here. I'm not even really focused on u substitution yet. I'm just going to see, can I rewrite the problem so that's easier? I'm going to distribute. It's kind of like the second half of the TOCO problem. So x to the 1/2 times x, I would add the exponents, and that's going to give me x to the 3/2. X to the 1/2 times 1, well, that's just x to the 1/2. And then we integrate. Okay, 1 over something. 3/2 plus 1, that's 5/2. That's what we put down right there. Okay, 1 over, again, add 1, that makes 3/2. And if you feel comfortable going ahead and calling this 2/5 and 2/3, great. You're going to need to do that eventually in this problem. Because once you plug in your bounds, and I didn't need to change the bounds because I didn't do use substitution. Taking 1 to 5/2 is really no big deal. Okay, same with 0. By the way, all of this in here is going to be 0. You recognize that early, it saves you some work. That's no big deal, but you're going to have to at some point call that 2/5 and 2/3, and you're going to need to get a common denominator here. So that's going to be 15. So if I make 15 times 3, that's 6, times 5, that's 10, 16/15. So kind of annoying arithmetic at the end, not too bad though. Alright, you're going to do 6, 7, 8, and 9 all on your own. And I think 10's on the next page. Yep, we're going to do 10 together. And so looking at this problem, it's a little bit different because it's differential equation. That just means move the dx over and integrate. Okay, now this means we have to be able to integrate sine x times. And I'm going to go ahead and put this cosine x in parentheses. That's going to make figuring out what my u equals a little bit easier. So if u is the thing in parentheses, du is going to be its derivative. It's negative sine x dx. The negative can get moved out to the front pretty easily. If you notice, all of that is taken care of in the problem. So I'm left with u squared du, which is easy to integrate. That's 1/3 u cubed plus c. They give us some information in order to find the plus c. They tell us that y should equal 0. And I really should have, hold on, I'm going to get ahead of myself here because I still have u there. I need to go ahead and rewrite this so that instead of u, I have a cosine x. And I noticed that because I was like, where do I plug in x? It wasn't there. Okay, now I'm going to plug in that initial condition. Now I'm going to, I'll kind of move up here. Now I'm going to plug 0 in for y. And I'm going to plug pi over 2 in for x. So a little bit of trig. Got to be able to figure out what pi over 2 cosine of that is. Again, if you kind of use this little chart here, cosine is going to be the 0. So you end up getting c equals 0. Alright, so all of that for not a whole lot. Then it says, what is the value of y when x equals 0? So my y is going to be negative 1/3 cosine of 0. And then I'm not going to put anything here because the plus c turned into plus 0. But what is cosine of 0? It is 1. So you end up just getting negative 1/3. Alright, you're going to do 11 and 12 on your own. I'm going to have you skip 13. Not a bad problem. There's just, this is one of the longer packets. Okay, 14, let's do this one together. So this is kind of similar to that 13. They give us some information here, but then what we really want to know is, what is this equal? Alright, so let's think about this. So let's split this up. Let's use what we know about integration. So I can integrate just f of x. Okay, and then I can integrate just 5. Do each piece separately. The reason this works is because they tell us what the first piece should equal. It should equal a plus 2b. This one we're going to have to work for it a little bit. Antiderivative of 5 would be 5x. And then we plug in the b. 5b minus, now we plug in the a, 5a. So it's a matter of simplifying, combining like terms. 2b plus 5b, that would be 7b, and a minus 5a would be minus 4a. So it was like we didn't really know where it was going, but you just do the things that you know how to do, which is split up integrals and plug in and everything. I'm going to let you skip 15. Okay, 16, 17, and 18 you're going to do on your own. Oops, let's go back here real quick. I'll let you skip 19. And let's do a free response. Let's do 20. So this is the graph of f prime. All right, and it says write an expression for f prime. All right, this, you could do this as an absolute value. I'm going to use this as a piecewise function. It's going to make integrating a little bit easier. So what would this line be? It would just be y equals x, okay? And then, because this is the graph of f prime, so that's all we're doing right now. And then this would start at 0, and this would end at 1. Okay, this line, if you think about it, going up here, it's going to, y-intercept is going to be 2, and it's going to have a negative slope. So this is going to be negative x plus 2, and it starts at 1, and it ends at 2. All right, that was stuff we did at the beginning of the year. The reason is because in this problem, we're writing an expression for f, so we've got to integrate. Okay, so let's think about what this would equal. What is the integral of x? It's 1/2 x squared plus c. Don't forget that. Okay, we're going to have to find this c here in just a minute, and that could be c sub 1. And down here I'm going to have negative 1/2 x squared plus 2x plus c sub 2. We don't know that those c's are the same. Probably they're not. We do know our initial condition, and this helps us find our c. Okay, so let's think about this. This would mean that we have a 1/2. We plug in a 1. Hold on. I'm going to change up my little notation here. Let's just do the first part. 1/2 times 1 squared plus c sub 1. That should equal 0. So this means that c sub 1 should be negative 1/2. It's kind of like that goes away. A half plus c equals 0. C has to be negative half. All right, so now we do the other piece. Negative 1/2, again, times 1 squared plus 2 times 1 plus c sub 2. That also should equal 0. So all of this over here ends up being 3/2. So c sub 2 should be negative 3/2. All right, so what we end up having is, just writing my final answer here. Instead of plus c sub 1, I'm going to write minus 1/2. I'm just finding the c. The only difference is it's in a piecewise function. I'm going to have negative 1/2 x squared plus 2x. Again, instead of plus that c, I'm going to write minus 3/2. Kind of getting tight here, but we'll squeeze it in. So there should be a 2 there. All right, so there you go. Now we're going to sketch the graph. Okay, I'm going to actually do it on this graph up here. I want to show you something that happens. I'm basically graphing what I found in part B. Okay, and keep in mind they told us that f of 1 is 0. So I'm going to plot that point. Okay, what would be this parabola? It would kind of cut down here, and it would be opening up like that. Okay, this parabola would be opening down, all right? And so it's going to look something like this. Okay, what they're looking for here is that you understand what the parent function is, and that I kind of messed up just a little bit. That wasn't wrong, it was just I need to go like this. Okay, and then you are going to do the last, you're going to do 21 and 22, and then you can skip 23. So part C, no. Okay,